All right, so last section we are going to look at is, it's called the law of sines. So this section is not abstract at all, very concrete. What we're looking for is how long are the sides in a triangle and how big are the angles. We've done this kind of thing before, but when we did it with right triangles. When you have a right triangle, you can use Sakatella and the Pythagorean theorem. If you have an oblique triangle, that means it's a triangle that does not have a 90. Well, if you don't have a 90, and you don't have a hypotenuse, no Pythagorean theorem. Okay, so when you're solving a triangle that does not have a 90, you cannot use Pythagorean theorem. So what do you use instead? You use the law of sines. So it's just a formula that we plug into, and then we get the answer. So two different types of triangles that don't have a 90. You could have an acute triangle. Think of like equilateral. That's an example. Or you could have an obtuse triangle where you have one angle bigger than 90. As far as your sketch, I usually sketch it like what's on the right. None of my sketches are to scale. The sketch is just there so I can see what is across from what. Because we're going to label the sides and the angles just like we did in right triangles. Now, what were the letters that we used for the sides?
ABC.
ABC. Well, angle was always across from A.
Alpha.
Alpha. Across from B.
Beta.
Beta, and that was it. We need a name now for this angle because it's no longer 90. That's going to be the Greek letter gamma. So that's our new diagram for solving triangles.
Greek letter what?
Gamma. G-A-M-M-A. So ABC for the sides. A across from alpha, B across from beta, nothing new there. But now C is across from what we call gamma. So there's two different laws that we learned, okay, to solve triangles that don't have 90s. There's the law of sines. There's also the law of cosines. You can't really use the laws interchangeably. Law of sines is for certain types of problems. Law of cosines is for other problems. Law of sines can be used in these three cases. Okay. Angle, side, angle. That would look something like this. They give you an angle, give you a side, and they give you an angle. That's an angle, side, angle problem. So the three letters are describing the information they give you and the placement. Two angles with a side between them. A-S-A. Yeah.
Does it have to be like, do they have to be next to each other? Like, or could it be that instead of that side that you have the long obtuse side?
No, that would be what we're gonna. That would be side angle angle. Okay. This one, the side has to be between the two angles.
Yeah.
The one that you just mentioned, that one would be more like this. Let's say they gave you side, angle, angle. Same way we basically solve it, but a little bit different layout of numbers. This time,
what
yeah.
if the two angles were in the two far corners and that 15 was on the left side?
So like if you had this over here, and then instead of that, you know, this number over here.
No, and then that 95 is where you crossed out. Like there's an angle there.
Oh, okay. So cross out what?
So just move the 95 to the right. Let's pretend that was the angle there.
So we'll make that 45.
Yeah, and then the 15 is on the left. Like,
if the 15 was over
so
here.
like the side of the two.
So now that is angle, angle, side. Yep, it's the same.
All right.
You can say it angle, angle, side, or side, angle, angle. That's the same thing. The point here is you've got two angles and a side, but the side is not between the two angles.
Sorry. I wanted to ask, is the thing recording?
I hope so.
Alright. Interested to see.
Thank you. And then the other type, this one's a little bit different. Okay, they give you two sides and an angle. And it has to be that way. It has to be two sides that you know, like 6, 12, and the angle that they give you cannot be between the two sides. So it cannot be the one in the lower right. If it was the one in the lower right, you're not solving it with this formula. It will not work. It's impossible. So it would have to be like this angle over here, or it could be the angle in the bottom left. But you've got two sides and an angle, and the angle is not where the two sides come together. It's not between the two sides. When it's between the two sides, that's called an SAS. The A is between the two sides. Okay, and that's law of cosines. So the two types of problems we cannot do with this law are side angle side and side side side. If you're given all the sides in a triangle, or you're given two sides and an angle between them, this law doesn't work.
Isn't this law of sine?
This is law of sines. So you can use it on these three cases.
You said cosine.
Yeah, so yeah, law of sine. So yeah, the law of sines is what we use for that. Law of cosines would be these. So we're not going to worry about those today. So any questions on the types of problems you use law of sines? Okay, so what is the law of sines? Okay, so to solve any of those three types, that is the law of sines. It's three fractions. You never use all three at the same time. You only use two at a time. But it says sine of alpha over A equals sine beta over B, which equals sine gamma over C. And you pick two parts at a time and you fill in. What ends up happening is when you use two parts, you create a proportion. 3 out of 4 of the spots in the proportion are going to be numbers. You're going to solve for the one thing that's not the number. How do you solve a proportion? Yeah.
Cross multiplication.
Yep. So every problem you do with law of sines is going to be cross multiplying. You do want to remember that all the angles in a triangle still have to add up to 180 degrees. That's always true. All right, so as far as the formula for that section, that's it. Those are all the notes. Now we'll just try two, maybe 3 examples. We'll see. Okay. Does everyone have the formula? Okay. All right, so let's solve the triangle. Okay, so first thing we want to do is we want to draw it and see if it's law of sines or law of cosines. Because when we do the next test next week, you're going to have some of each. Obviously, this week, you know it's always going to be law of sines. Okay. A, B, C, alpha, beta. Okay, let's start with A. Are we given that?
Yep.
Yep, what is it?
4.
So I'm going to make that a 4. Are we given B?
No.
C?
No.
No. Let's check the angles then. Alpha?
Yes.
Okay. So that's 20. How about beta?
60.
60. How about gamma?
We don't have that, but we can figure that out rather easily because we have 2 of the angles.
Yep. So we can figure it out very easily. So I'm just going to organize all my information on the side. So 20, 60, and 4. So, what does gamma have to be?
It's gonna have to be 100.
It's going to have to be 100. Yep. Now, when we did this before, I told you don't use something that you found to find something else. Because if you got it wrong, you're going to get something else wrong. That doesn't work in this section. You're going to have to use this 100 degrees to figure out C. There's no way around it. So that means if you got the 100 degrees wrong, C is going to be wrong as well. That won't have any effect on B. B is totally separate. That's a different row. So you could still get B right if you got gamma wrong. Okay, but any questions on gamma? So double check it, make sure it's right. Looks good. Okay. Now let's find B. Whenever you do law of sines, you're going to set up a proportion. Every law of sines problem looks like that. You always want to pick the row that has everything in it, and then the row for the letter you're trying to find. Which row has everything in it here? Yep, row A. So let's look up the law of sines that has these two things in it. Okay, it's
Sine alpha over A.
sine alpha over A. So we're going to fill that in on the left. Sine alpha over A. So sine 20 over 4. And what row are we trying to find something in?
B.
B. So look up the law of sines, look up the part that has the B in it.
Sine beta over B.
Sine beta over B. So we're not using the last part right now. Just the first two fractions. Sine beta over B. Okay. And what's beta? 60. 60 over B. And how do you solve a proportion? Cross multiply. B sine 20 equals 4 sine 60. And now we just have one step left to get B alone. What would be my last step?
Would it work to just plug the right side into the calculator?
No calculator yet.
We can divide both sides by sine 20 degrees.
I don't want to type anything in on the calculator as I go, because the more rounding I do, the less accurate it becomes. So I'm going to type everything in exactly like that, and that's my answer for B. 4 sine 60 over sine 20. 4 sine 60, close your parenthesis, divided by sine 20. Doesn't matter if you close it, because you don't have anything coming after it. B is 10.128. That's pretty much how every law of sines problem goes. It's very concrete, very numerical. Let's find C, the same way. Well, now you have two rows that have everything in them. Which row do you think I should use?
We should still use the one that we began with.
Yeah, use the one that was given because we know it's right. Sine of alpha over A. What was A again? 4? Okay. So you always have to pick two rows. Use the row that was given, and we're trying to find this now. What's the law of sines that has the C and the gamma? What does that look like?
Sine gamma over C.
Sine gamma over C. So cross multiply. And what I do when I cross multiply is I usually do this part in my head. It's going to be 4 times the sine of 100 divided by the sine of 20.
It's going to equal 11.518
Okay,
when you round it.
11.518. Thank you.
So what happens to the sine over beta when
what happens to the...
If you go to that equation that you had before, like with all the signs, no, up more like the signs over alpha, beta, and gamma. How come you can? Oh, because they're all equals. I thought it
They're
was,
all equal to each other. So you can set this one equal to this one, you can set that one equal to that one, or the last one equal to the first one. Yep, they're all equal. That's a good question. That's it. That's a law of science problem. All right, let's try the beginning of this one. We'll do the first answer, but then I want to do the last question because the first two types are very similar. The third type is a little different, but it's still something you've done before. Okay, let's make our chart. Okay, do we know A?
No.
No. Do we know B?
No.
Okay. Do we know C?
Yes, it's 4.
Okay. Do we know alpha?
Yeah, that's 45.
Do we know beta?
That's 40.
And do we know gamma?
No, but it's very simple to figure out. It's going to be...
So remember what I said about law of science. It only works if you have a full row. You've got to have a row where you know everything. Were we given a row where we know everything?
We aren't given that.
We weren't given a row where we know everything, but we can find one. And it's extremely important we find it correctly because the row that has everything in it is used to find everything else. So this time, if we get gamma wrong, it's going to affect all the answers.
Gamma is going to be 95 degrees.
Yes. So gamma is going to be 95, and it's very important we get gamma correct. Now let's just find A, and that's where I'll stop with this one because I want to just spend the last 10 minutes on the last question. 5 minutes or so. Okay. Somebody tell me what I would put on the left side. Sophia?
Sine of 90 degrees, well, or the second. Or sine
Sine.
of sine 45
Okay, we could do that. Sine 45. Yep.
over A.
Perfect. Can somebody tell me about the other side? Yep.
Sine of 95 degrees over A.
Yep. Sine 95 over 4. And how are we going to solve that? Cross multiply. Can anybody tell me, not the decimal, but just tell me what times what divided by what? Max?
4 sine 45 divided by sine 95.
Yep. 4 sine 45 over sine 95.
It's going to come out to 2.839.
Okay, thank you very much. 2.839. Now, a couple things you can look at. The biggest side should always be with the biggest angle, and the smallest side should be with the smallest angle. So I know my last answer should be smaller than 2.8. Maybe it's like 2.5, 2.6, I don't know. But it has to be smaller than 2.8. Any question on how you get B on that one? This would count as 3 answers on the test. So when I give this one question, I would count, basically each box would be 1 point.
B is going to be 2.581.
It comes out to 2.581?
Yeah.
Okay, thank you.
It's rounded after that last one back there, but
Now, in both of those problems, they started you off with 2 angles. In this problem, they're starting you off with 1 angle. This one is a little different. You can't just add 2 angles together and subtract from 180 this time, because you don't have 2 angles. Let's draw it and see what it looks like. Okay, so let's do A. B, and there's alpha. A has to go across from alpha. What kind of triangle is that using the 3 letters? Like the A's and the S's, yeah? That's a side, and an angle that's not between the 2 sides. Okay, side, angle. When you're doing law of sines, when you have side, angle, there's 3 things that could happen. When you do the other 2 kinds of problems we already did, there's only one thing that can happen.
What's wrong?
Let's see. The only thing that can happen on the other kinds of problems is you solve it and you get one answer. And that's exactly what we got. When you solve a side, angle problem, it could end up being exactly like the kind of problems we just did. You start to solve it, you get one answer. You could start to solve it and you get 2 answers. So when I say 2 answers, I mean 2 answers for everything that's in the boxes. The stuff you had to find. Like you get 2 different answers here, 2 here, 2 there. Or the opposite case, the fastest case, is when you start to solve it and you realize that it's impossible. They gave you a problem that there is no solution. The kind of problem that you'll see on the test tomorrow, I would expect it to be very similar to example 3, as far as the law of sines problem. So I'll give you one like that, I'll give you one like that, and I'll give you one like that. So even though it's 3 questions, that's really going to be almost half the test, because that's going to be 3 answers per question. Okay, so this will be worth like 9 points on the test.
What would it look like if there's no answers?
Well, if that's what ends up happening in this problem, then I would worry about that. But if it doesn't happen, I wouldn't worry about it for tomorrow's test. But if you want to know what it would look like visually, I can just show you quick. It would look like this. The sides it wouldn't be physically capable for the sides to connect. There'd be a gap in the 2 sides. That's basically what it would look like. The gap could be in different spots, but there'd be a gap. Yep.
Like if you got 90, 45, and 50 or something somehow as angles, that would be no solution?
I have to think about it, but let's focus on this one.
Yeah.
Don't worry about if it doesn't happen, you don't need to know it for the test tomorrow.
Got it.
I plan on covering the things that we don't cover in the next lesson.
Got it.
The thing that we are going to cover is going to be on the test.
Got it.
Yeah?
I've got the answers for theta and gamma.
Okay, let's just go ahead and just draw everything out first. 3, 2, 40. Can I do Pythagorean theorem to get the 3rd side?
Yes.
No, you can't.
No.
For a triangle.
Right. If you use Pythagorean theorem, then you're assuming this is automatically 90, which it probably is not.
It is not.
All right. So if there's a row that's missing everything, you need to forget about that row for now. A row that's empty is useless. The only thing the law of sines can use is a full row, or a partial row is okay, but not an empty row. Okay, empty rows we got to come back to later. So that forces me to find something first. What do I have to find first? Yeah, beta. I have to do beta first. So actually, you tell me what I'm going to fill in. Sine of what over what? Equals sine of what over what? Yep.
You're gonna have sine 40.
Yep.
And then you're gonna have the sine beta.
Beta over 2. Okay, big difference this time. The variable that you're solving for is in the trig function. It's not in the bottom of the fraction. So we're going to have to get rid of the trig function. All right, so we want to get sine beta by itself. We don't even need to cross multiply. I just need to get the 2 on the other side. How would I get the 2 on the other side? Yeah?
Just multiply by 2.
Just multiply by 2.
There's one last step. For this.
There's one last step. How do we get beta alone?
You have to inverse sine everything.
Yep.
Which
So these cancel. Now, I just want to type in 2 sine 40 divided by 3. I just want to see what that is. Well, it's not bigger than 1 or smaller than -1, so that's good. But what kind of number is it? It's a positive number. Okay, so keep that in mind. We originally had sine equal to a positive number. Okay. So let's do the inverse sine of that. I don't have to type it again. I can just use the last answer I had on the screen. And I get 25.374. If this was a no solution, I would know that right now. I would have got an error. And that's because I would have been taking the inverse sine of a number bigger than 1. But that didn't happen. So 25.374. Okay, so I'm going to write that down. I usually put it a little higher in the box, just in case there's a second answer. I'll write it below it. Sine equals a positive number. We got an answer here. What other quadrant is sine positive in? The second.
it's
How do you get your answer in the second quadrant?
you'd have to subtract 180 from that answer that you have.
Subtract that answer from 180.
Yeah.
So
Yeah.
take 180 minus 25.374.
Oh, you put negative there.
374. That's the potential other answer.
It's not going to work out because we already have a 40 and we can't go over 180, so it's not going to work for that.
Right. So the way you determine if the second answer works is basically does it fit? If there's a second answer, it's in quadrant 2. It's 154. But you were already given a 40. You cannot fit 154 and 40 in the same triangle. That means we don't need the second answer, and this problem is exactly like the first two now. So is there any question how I got the 154, or how I determined it does not doesn't fit?
So if there were 2, you just like do this same so just twice.
Yeah, it's not a harder problem, it's a longer problem. You have to do everything twice. But we don't have to worry about that in this one. Alright, so now I know 2 out of 3 of my angles. So what could I figure out?
We can figure out gamma,
We can figure out gamma.
which is just going to be adding the 2 angles and subtracting.
So when I add those 2 angles, I get 65.374. I subtracted it from 180, and I get 114.626. Now we can find C. And that's our last step.
Yeah.
Have to do it in the order I showed you.
The equation that you're going to use for this, just so finding C is going to be C is equal to 3 sine the gamma divided by sine alpha.
Can you say that again?
3, I didn't put it into that formula right there.
Oh, you just went right to the final answer?
I brought it out to the final formula,
Yeah.
which is going to be 3 sine 100.
What's going to go on the top right?
The top right is
Sine 114.626 divided by
C.
C. Sine of alpha over A, sine of gamma over C. So what's my formula for C look like?
It's
Division. Yeah, Lily.
3 sine 1/4 over sine
6. And now I need a calculator, but nothing you need a graphing calculator for.
It's
Yep, what is it?
C is going to equal 4.243.
Okay, so not once in this section did I go to a graphing calculator and hit y equals and type something in on a graph. So for tomorrow, pretty much the only thing you'll be able to use just a regular calculator. Okay. Any questions on that? Okay. Okay, so the homework is 7 questions. So I want you to do 5. I want you to do 5 through 7 there. 5, 6, 7, 10, 16. And then these 2 problems, just call them problem A and B. They're on the test, and the book didn't have one like that. Okay. While you guys are at lunch, I'll put the test topics on the side of the homework.